Hey, welcome back to the second part of our trigonometry review for exam 2. Here we're going through the practice tests that we've uploaded to D2L, and we've got 7 more problems to get through, so let's get started. Number 8, establish the identity. Show every step required and list any properties used. Okay, so the first step is to work on the more complicated side so that we can produce the other side. Notice that we're trying to add two fractions here. So what do you have to add or subtract fractions? You have to have a common denominator. So the common denominator here is going to be cosine t times 1 plus sine t. That's going to be our common denominator. And so the 1 plus sine t in the first fraction got multiplied by the cosine t. Whatever you do to the bottom, you have to do to the top. If I multiply cosine t times cosine t, I'm going to get cosine squared t. And then plus, from the fractions, we have a plus. And the other denominator, the cosine t, got multiplied by the 1 plus sine t. Whatever you do to the bottom, you have to do to the top. So if I multiply 1 plus sine t times itself, I'm going to get 1 plus sine t squared. And then that's going to have to be FOILed. Okay, so the next step is we're going to have cosine squared t plus 1 plus sine t times 1 plus sine t. And that's all over the common denominator, cosine t, 1 plus sine t. And then we're going to carry that on up to the top here, okay? So we're going to have cosine squared t plus, and then doing the FOIL method, 1 times 1 is 1. On the outside, we have a plus sine t. On the inside, we have a plus sine t. Last but not least, we have a sine squared t all over the common denominator. And a lot of people will get in the habit of dropping that. You do need to write it every time. Next step, this is where we get to use an identity. Notice I've got sine squared t plus cosine squared t. So sine squared t plus cosine squared t, we can replace that with 1, which I can then add to this 1 and get 2. So again, sine squared t plus cosine squared t gave me 1. That's a Pythagorean identity. And I went ahead and added it to the like term, the other 1, and got 2. And then I'm going to combine like terms. I've got 2 sine t's all over the common denominator. Now, what identity did I use from this step to this step? I used a Pythagorean identity. So where it says to list any properties used, you would want to list Pythagorean identity. We used a Pythagorean identity there. Next step, from the numerator, I'm going to factor out a 2. Notice both of these terms have a 2, so we're going to say 2, 1 plus sine t, all over the common denominator of cosine t, 1 plus sine t, and then your 1 plus sine t's, the common factor is going to reduce. So that's going to leave us with 2 over cosine t, which we could also write as 2 times 1 over cosine t. And we know that 1 over cosine is the secant. So then that would equal to 2 secant t, which that is now equal to the other side. and we're done. So again, this is kind of messy. Remember, you can use your own scratch work and make it nice, maybe all on one sheet. You don't have to do your work on the exam. You can do nice scratch work, okay? So that kind of shows all the steps involved to prove that identity. Next, find the exact value of the expression. Sine of negative 11 pi over 12. It doesn't say what, if any, properties to use, so we can use whatever we can find to work here to make negative 11 pi over 12. Negative 6 and 5. Negative 6 pi over 12 minus 5 pi over 12. That would make negative 11 pi over 12. But 5/12 is not a unit circle angle. And so we're going to have to find some other way to make negative 11 pi over 12. But let's start with 2 pi over 12. And if you're wondering what's going on, this is how you work this. You just guess. 2 pi over 12 would reduce to pi over 6. That's a unit circle angle. And then what would I subtract from that to get negative 11 pi over 12? Would it be 11, 12, 13 pi over 12? That would give me negative 11 pi over 12, but 13/12 is not in the unit circle. So let's kick this up one. Instead of 2, let's say 3 pi over 12 minus 14 pi over 12. That makes negative 11 pi over 12. And 3/12 is a fourth. And 14 over 12 reduces to 7/6. Hey, those are unit circle angles. So here what we now have sine of alpha minus beta, and we can use a sum and difference formula. Okay, so we're looking for the sum or difference formula for sine of alpha minus beta. And that is sine alpha cosine beta. For sine of alpha minus beta, it's minus cosine alpha sine beta. So do you see, with just a little bit of thinking, we came up with two angles that are in the unit circle that do produce negative 11 pi over 12, and we have an identity, a formula for that. And so now we're going to just do a little plug and play here. Sine of alpha is pi over 4. Cosine of 7 pi over 6 minus cosine of pi over 4 sine of 7 pi over 6. And now it's time to go to the unit circle. Sine is y. That's going to be square root of 2 over 2 at pi over 4. And at 7 pi over 6, we need the x. That is negative square root of 3 over 2 minus cosine at pi over 4, square root of 2 over 2, sine, which is y, at negative pi over 6 is, at 7 pi over 6 is negative half. And then we need to simplify that. So that's going to give us negative square root of 6 over 4. And here a negative times a negative makes a positive square root of 2 over 4. And then if we want to make that nice and put it into one single fraction, we could say square root of 2 minus square root of 6 over 4. Do you see how I switch places with those? So that the positive one comes first. That's not necessary, but it's nice. And if we could bring up the calculator to verify that. In radian mode, we want to calculate the sine of negative 11 pi over 12. And look, the calculator put the negative square root of 6 first. Okay, so either way is fine. Switching them around is not going to make it wrong. It's just different. Okay, but it is verified here with the calculator. Don't forget, you got to show the work though if you want to get credit. Next, find the exact value. Here we have cosine alpha cosine beta plus sine alpha sine beta. And so we're going to need to find a formula for cosine alpha cosine beta plus sine alpha sine beta. And that formula is cosine of alpha minus beta. That is the sum and difference formula for cosine of alpha minus beta. And so this is going to work out to be cosine of 2 pi over 9 minus pi over 18. And you're going to need to subtract those. 2 ninths is the same as 4 eighteenths. 4 minus 1, that's 3 eighteenths, which reduces to pi over 6. And what is the x-coordinate at pi over 6? That is square root of 3 over 2. And that should be done. And I think by now y'all figured out that I do like to check with the calculator. And so give me just a moment. It's going to take just a little bit of button pushing. But I think it's worth it to make sure that you get it right. Cosine of 2 pi over 9, cosine of pi over 18, plus sine 2 pi over 9, sine of pi over 18. .866. 0.866. Well, what is square root of 3 over 2? 0.866. Verified. Whew, checking it. Next, use the information given to find the exact value of the indicated expression. Here, look what it says to find. Sine of 2 theta, cosine 2 theta, sine of theta over 2, cosine theta over 2. And we're given that secant is negative 3 square root of 5 over 5. The reciprocal of secant is cosine. So if I replace secant with 1 over cosine is negative 3 square root of 5 over 5. And then if I flip both sides, that's going to give me cosine is negative 5 over 3 square root of 5. If I rationalize that, that's going to give me negative 5 square root of 5 over 3 times 5. Those 5's will cancel. Negative square root of 5 over 3. All right, so there's cosine of theta. Man, if I only knew what sine of theta was. Well, isn't cosine x over r? And if I know x and r, I can get y. Let's use the Pythagorean theorem. X squared plus y squared equals r squared. That's going to cancel. Bring the 5 over. Makes it a minus 5. Y squared is 9 minus 5, which is 4. And that means y is 2. So that means that the sine of theta is y over r, which would be 2 over 3. So I now know cosine theta And I now know sine of theta. Surely I can get the rest of these problems now that I have that starting point. Got to do a little bit of work here in the beginning so that we can apply these double angle formulas and half angle formulas. So what is the formula for sine of 2 theta? That is 2 sine theta cosine theta. So the sine of 2 theta is going to be 2 sine theta, which is 2/3, cosine theta, which is negative square root of 5/3. And then all I got to do is multiply straight across. 2 times 2 is 4. That's going to be negative 4 square root of 5/3 times 3 is 9. Sine of 2 theta is done. Next, cosine of 2 theta. Well, we've got 3 formulas for cosine of 2 theta. And I'm going to pick the one that says 1 minus 2 sine squared theta. 1 minus 2 sine theta squared. And sine theta is 2/3. And then if I pull out my handy dandy calculator, 1 minus 2 times 2/3 squared is 1/9. So cosine of 2 theta is 1/9. Next, sine of theta over 2. Do we have a half angle formula for sine theta over 2? We sure do. It's plus or minus square root of 1 minus cosine theta over 2. Now, plus or minus, okay? So that means that we need to figure out what quadrant we're in so that we can know what that answer is going to be. Well, back to the beginning. Remember, secant related to cosine, cosecant related to sine, and notice that cosine is negative, but sine is positive. So where is sine positive other than quadrant 1? That's going to be quadrant 2. So this is a quadrant 2 angle. So sine of theta over 2, if this is a quadrant 2 angle, we're going to end up using the positive square root of 1 minus cosine theta, which is negative square root of 5/3, all over 2. And then we need to simplify that. Okay, so 2 negatives make a positive, and that's going to be square root of 3. I can make the 1 into 3/3, so that'll be 3 plus square root 5/3 over 2, which will be over 6. And the last thing I need is cosine of theta over 2. Square root of 1 plus cosine theta over 2. And so if I simplify that, cosine theta over 2, that's going to be the square root of, again, 1 is 3/3. That'll be 3 minus square root of 5. Over 3 over 2 makes over 6. And we're going to call that good. Next, number 12. Solve the equation for the exact solutions on the interval from 0 to 2 pi. And so here, the first thing I notice is that I do have a cosine of 2 theta, and the other trig function is cosine theta, and I said theta, I mean x. Cosine of 2x, the other trig function is also cosine. So we're going to have to deal with the double angle formula. Remember, for cosine of 2x, we have 3 of those. I'm going to choose 2 cosine squared theta minus 1 because of the other trig function being in terms of cosine. Okay, so I've got my cosine squared x plus, and for cosine of 2x, that's going to be 2 cosine squared x minus 1. Oh, and don't forget about your plus 1 that's already there. And then if I combine like terms, that's going to be 3 cosine squared x. Negative 1 plus 1 cancel. Divide both sides by 3. Gives me cosine squared x equal to 0. Taking the square root of both sides. Cosine of x equals 0. Now then, cosine in the unit circle, cosine is x. And so we're looking for the radian angles where we have an x-coordinate of 0. And there's 2 of those. There's 2 radian angles that have an x-coordinate of 0. So x, remember x is my theta this time, so the angles are going to be pi over 2 and 3 pi over 2. And there's that equation solved. And we've got 2 more to go. We've got cosine alpha times cosine of beta. We're going to express this product as a sum. And do we have a formula for cosine alpha, cosine beta? Cosine alpha, cosine beta is 1/2 cosine of alpha minus beta plus cosine of alpha plus beta. So there's the formula for cosine alpha times cosine beta. All we have to do is replace alpha and beta with 5 theta and 4 theta respectively, and simplify. 1/2 cosine of 5 theta minus 4 theta, that's theta. Cosine of 5 theta plus 4 theta, that's 9 theta. And that is done. Last one, we have sine alpha minus sine beta. Express the sum or difference as a product. So the formula for sine alpha minus sine beta is 2 sine of alpha minus beta over 2 cosine of alpha plus beta over 2. So here, once again, once you find the appropriate formula, here we needed sine alpha minus sine beta, then it's just a matter of doing plug and play, replacing alpha and beta with 10 theta and 4 theta. All right, so here we go. 10 minus 4 is 6 theta over 2. And 10 plus 4 is 14 theta over 2. And then that's going to simplify to 2 sine 3 theta cosine of 7 theta. And we're done. And we're done with the exam. So, if you have any questions or comments over anything that I've covered, feel free to leave those in the comment section below, or you can text me. And thanks for watching.